Welcome everybody. Thank you for coming to our CLF Alberta webinar event. We're very excited to have some great speakers today from Volcraft Canada, and also that it's worth some AIA credits. So that was a nice little surprise. I think it's recently accredited, so that was great. We have been doing a lot and we've been very busy at CLF Alberta. We've just joined up with ENBIX. Hopefully you saw that news on our LinkedIn page. So that's the Emissions Neutral Building Information Exchange. So it completely aligns with our goals at CLF Alberta of radically reducing embodied carbon in buildings and infrastructure. So we're so excited to partner with them. So you'll see kind of the words Alberta Eco Trust and ENBIX floating around. And yeah, now we're so happy to be partnered with them. So they're focusing on all sorts of emissions neutral stuff. And so we'll make sure to introduce Joe and let them talk about that. But I wanted to talk about a few more things first. First and foremost, we are looking for volunteers. So I'll ask Christina to put the link in the chat, but just so everybody knows, we're ready to go. We've had Christine and I have been volunteering for a while now, and we're ready to open the gates with our ENBIX support as well. So please reach out and see any more information on that link in the chat. And of course on the ENBIX website. And that means that our newsletter has changed as well. So we encourage you to sign up to the ENBIX newsletter, which will feature CLF and embodied carbon information. So Christina will put that link in the chat as well. So definitely a few administrative things for you to do, but wanted to get that information out to everybody. So if you're involved in embodied carbon, please volunteer and sign up for the newsletter. I think that takes care of all the housekeeping, and I will now pass it over to Joe. So Joe is from ENBIX, so he's going to tell us a little bit about it. So please, and I will pass the sharing on to you.
Awesome. Thanks so much, Kristen. Everyone should be seeing my Alberta Eco Trust slide now. So good afternoon, everyone. Welcome. My name is Joseph Henke. I'm a program specialist with ENBIX. We're part of the Alberta Eco Trust Foundation. Thanks for joining us today, and I'm excited to talk about environmental product declarations with our two guests. I'm especially excited to talk about steel. Anybody who knows me knows any chance I get to talk about steel manufacturing, and it's great to share that with people in the audience today. But for the moment, I just want to talk a little bit about Alberta Eco Trust and ENBIX. So Alberta Eco Trust is a charity that's been supporting and leading environmental initiatives in Alberta for over 30 years. We've often in the past done that through granting initiatives, but more recently what we've done is we've started to expand into our buildings initiatives. Our buildings initiatives covers two different aspects. We have our ENBIX, which is what I'm part of. ENBIX is the Emissions Neutral Building Information Exchange. We seek to support industry through collaborative efforts, peer-to-peer learning, resource development, sharing. We're really out there to try and fill the knowledge gap and help organizations develop capacity building and skills in order to achieve emissions neutral future in Alberta. Our other initiative is our Retrofit Accelerator, which just launched this past September. The Retrofit Accelerator, it consists of free coaching services for building owners and operators who are on a journey towards a deep energy retrofit where they're looking to make a step change in their energy and consumption. So this is a great program. We're really hoping that people will take time to participate. People who are connected with the building industry might have been seeing it promoted through both the cities of Edmonton and Calgary, as well as other areas. So it's a really great opportunity for building owners to access knowledge and information about the deep energy retrofit. So with that, I'll hand it back to Kristen, and we to go from there.
Thanks, Joe. And yeah, as mentioned, definitely check out the website. There's tons of information on the ENBIX website and also on our CLF Alberta one as well. But as you can imagine that with a lot of types of different emissions neutral options, ENBIX is the place to go for those resources in Alberta. Okay, we're getting to the main event. So excited to have Gerard and Alex with us here from Volcraft. I'll let them introduce themselves more thoroughly, but we'll let them get started and make sure we're on time and open the floor to them. Thank you so much for coming, and thank you to everybody for attending.
Yeah, thank you so much. So myself and Alex, we are both from Volcraft. I am Gerard Gosine. I'm the district sales manager for Volcraft Canada, and I'm located in Calgary. I'm also Volcraft Canada West's product champion for sustainability for our Western division.
Yep, and I'm Alex Brown. I'm actually stateside. I live in the Chicago area, so at the risk of being told to leave, go Blackhawks. And then also listed there is a colleague of ours who's not present today. Laura Michelli is our internal sustainability expert. So she developed a lot of this content, and she's been super helpful in getting us on kind of the commercial side and engineering side educated on this stuff. So we wanted to put her information out there as well, just so that you all know that she's a contact for you folks too. And then, yeah, as mentioned, this is accredited through the AIA for one learning unit. So we've got some language here just talking about what that means. And then at the very end of the presentation, we'll have a QR code. So you can scan that, and that will take you to a short survey, as well as a submittal form with your information so that we can get you your credits. If you have an AIA number, we will report that on your behalf. But if you don't have a number, or if you don't need it reported through the system for whatever reason, we can also email you a certificate. So all of that will be in the QR code at the end.
Great. Thank you, Alex. So let's dive right in. Today, we want to understand the life cycle and stages regarding joist and deck, comprehend the sources of carbon's emissions associated with that, demonstrate why steel joists and deck provide an excellent option for your sustainability needs, and just be familiar with the concept of a circular economy in regards to construction. So with circular steel, that's what we'll cover first, followed by we'll go into an overview of the joist and deck manufacturing process, then our EPDs, or environmental product declarations, how you can specify sustainable steel, and then also decarbonizing now for your project needs. So circular steel, what is it? Well, involved in circular steel, what we're specifically talking about is your carbon. So operational carbon examples are something like the electricity used to turn on your lights, natural gas for your heaters, water usage, and the carbon emitting ways those utilities are generated. Operational carbon is just a piece of the overall carbon pie. Additionally, the main focus when considering things like lead was historically just operational carbon, but in the last couple of years, there's been a shift to include embodied carbon as well. So just looking at the graphic here, that blue is just the operational carbon, and that was kind of the consideration for lead for the longest time. But in order to try and bring down that carbon footprint, it's been expanded to include everything from cradle to grave, basically. Some examples of embodied carbon would be the emissions from the mining of raw materials, electricity used to run the machines to process them. So that's that entire pie that I was talking about. And measuring operational carbon in lead calculations is a good start, but we can do better. And this is why there's an expansion to include embodied carbon as well as operational carbon. So greenhouse gas emissions. The majority of greenhouse gas emissions stem from the steelmaking process, like 90 to 92% of greenhouse gas emissions comes from that first step. Where steel comes from really matters. The predominant production method internationally is the use of blast furnace or blast oxygen furnace, which is kind of your quote unquote old school method of creating steel. However, when you come stateside, the construction products sourced from US manufacturers are more environmentally friendly than those sourced offshore. The construction industry generates an estimated 39% of the world's carbon emissions, according to the World Green Building Council. North America has the most advanced green building market, with commercial and government sectors alike continuing to drive the uptake of sustainable building best practices. So what are the two processes used for steel making? One is extractive, the other is circular. When looking at extractive steel making, it's really the mining and the blast furnace technology that are really carbon intensive. When you compare that to the circular steel making process, it can and does use the end of life steel from the extractive process, thereby reducing the embodied carbon content. And that circular steel making process, you'll take your end of life steel, it gets processed, it gets melted down in an electric arc furnace, and then gets used. And once that project or use is done, the cycle starts all over again. So you're not digging up any new material, new iron ore for your steel. The great thing about steel, if you didn't already know, it can be recycled and reused infinitely without a loss of mechanical properties. So the steel making process, when you compare the two, blast furnace to electric arc furnace, much of the greenhouse gas emissions associated with steel stem from the production of liquid steel. Two main types of technology that are used are the integrated mill and the scrap-based mini mill. In an integrated mill, liquid steel is produced through an integrated blast furnace and a basic oxygen furnace. In that blast furnace, oxygen furnace process, the main source of CO2 emissions stems from iron production, which among other processes involves burning iron ore and coking coal. A second method to produce liquid steel is through electric arc furnaces, otherwise known as mini mills. Mini mills use steel scrap for the most part. In that EAF, electric arc furnace steel making process, most of the CO2 emissions are associated with the electricity usage. So that would be whether it could be hydro or coal or nuclear or whatever. Once that liquid steel is produced by the blast furnace or oxygen furnace or electric arc furnace, then the process of forming the steel products is essentially the same. The liquid steel is poured into a ladle, then it's stirred, then poured into a caster to achieve the desired semi-finished shape. After that, steel is then cooled, reheated, and shaped into various products at the rolling mill. For joists, mainly long products are used, and for steel deck, coils are then used.
Once sorted, our cranes drop the scrap into our EAF furnaces, which are the driving force behind our steelmaking process. The EAF uses electricity to melt the scrap down to 3,000 degree Fahrenheit molten steel. This process is significantly more energy efficient than traditional steel furnaces. These strands, usually called billets, slabs, or blooms, are trimmed in preparation for rolling. To reduce a steel slab into a final product requires pressure, a lot of it. Once finished, our steel products are packaged and shipped via barge, rail, and truck to customers across North America. Once sorted, our cranes drop.
So what are we looking at in terms of recycled content? When it comes to joists, the recycled content in that electric arc furnace technology is about 97%, so really high. Deck, a little bit less at 60%. And our products across the board for joist and deck average about 77% recycled content. Just something to note that the blast furnace technology does produce slightly cleaner steel for coils, which affects the usage for light gauge applications such as the automotive industry. So industries like that, they would lean towards that blast furnace technology. At this point, I'll just flip it over to Alex, and he'll run over the manufacturing portion with you.
Yeah, and before getting into this, just there was a comment made by Forrest, and thank you, you're spot on, that yeah, North American steel, you can't generalize to say that it's better or worse than anywhere else internationally. It really comes down to whether it's a blast furnace or an electric arc furnace operation. It happens to be in North America, most major manufacturers are using electric arc furnaces, but yeah, that's not a given. And in the back half of this presentation, when we get into the environmental product declarations, that's going to come into play on kind of how you can tell where that steel is coming from and what that means. Let me switch to my screen here, which should be the exact same slide you were seeing before. But then this one's different. Yeah, so once that raw steel is made, whether it's a coil, as we saw in the video, or if it's like an angle or round or bar, on the Volcraft side, we're going to take those materials and turn it into joist and decking. So you can see a map of America and Canada here showing all of our different Volcraft locations. And then, of course, for Western Canada, the Alberta plant in Leduc is going to be primarily supplying that area. And there's just a pretty picture of the front of the building. But all of that manufacturing happens for Leduc within this facility. And it follows, you know, it's got its own process as well. So transporting the raw materials, accepting them on site, storing them, cutting everything, doing the prep work, and then doing that assembly and welding, dipping it into a primer and shipping it to the job site ultimately. So we'll go through all of those here in a little more detail. So you can see some of that storage here, just from like an engineering perspective. To make, you know, any kind of a truss shape, you know, we're able to control each individual member size. So we're able to optimize that to make it the lowest weight possible as an efficient design. So we've got to stock a lot of different material sizes in order to have that flexibility. So you can see all of that stored here, just stacks and stacks of angle. And then this particular video was taken at our Nebraska facility in America. So it doesn't look exactly the same, but it's the same procedure of handling that material, moving it, prepping it, staging it. You can see they're dropping the angle into place. The first guy here is going to be splicing two angles together to get what we call a chord, so the top or bottom members of the joist. And then those are going to be webs, so cut to length, crimped so that they'll fit inside of the cords, and everything is sort of staged ahead of time for our rigging crew. So you can see him kind of, you know, preparing everything, pulling everything into place. Then everything gets tack welded together and then clamped together at this part of the procedure. So because everything's cut to length, they can just kind of fit it in, and they know, you know, where the ends of those webs need to be, just because it's got to fit up correctly. Some of our facilities have lasers that will, you know, shoot down from the ceiling to help with placement. Here he's putting in one of the chord angles, and they're clamping the two of them together. And this process is always really cool to me. I mean, granted, I'm biased because I've gotten to live and breathe this stuff for a long time, but it's just so neat to see all of these like separate pieces sort of fly together, and then 30 seconds, you've got an assembled joist rolling down the line. And then you can see in the distance there, that's our welding pit. So all of these joists are just, you know, they're kind of loosely assembled. You know, they're really not capable of any sort of structural performance, but the weld is what's going to pull it all together so that you get that truss action. So you notice there's a couple of them stacked up there too in this shot. I think some of the other shots have 3 of them on their sides. And that's because we got that repetition of putting so long of a weld at such a thickness, one after the other. So you can see here, they're flipping the joist over so that none of our welds are upward or overhead. Everything is pointed down so we can apply it easier and get a more consistent welding performance. And I'll point out that every joist we manufacture has a specific location on a specific project. It's not like we build stock joists that, 50-foot lengths, and then you cut it down to what you need at your project. Just because of all the intricacies of building a truss and having all that load transfer the way we intend it to, we build them all custom length, custom loading depth for the specific job conditions. Then after everything's put together, we'll dip it in gray primer. Gray is the only color we offer. Kind of have the old Ford Model T attitude. You can have any color you want as long as it's black. But it's just a primer. It's compatible with most finish paints, and it's intended to minimize whatever rusting may want to occur on that bare steel. It's not going to prevent it completely. And in fact, yeah, up north, I hear you get snow. I certainly do here in Chicago. And I've seen joists, just get buried under a pile of snow for the whole winter. So it's not going to hold up to that kind of an ask. But just going down the truck, getting to the site, making sure it's properly covered, it should hold up pretty well there. And you can see some bullet points there, just kind of laying it out. One other thing they do in this stage is putting a joist tag on it. So that's a metal tag that identifies the manufacturer name. So in this case, Volcraft Canada, the project number, that 12124, et cetera number, and then the mark number, so J39. So on this particular project, within sequence 3, there is one design, one unique set of conditions that we call J39. So there could be a quantity of one of that joist. There could be 100 of them on the job, but they're all identical. And then that will correspond to the drawings we provide for the project so that the erector knows which one's which. We know, the inspector knows, et cetera. And then those will be tied with a wire to the end web of the joist. You can see with those red arrows there, always at one end or the other. We call it tag end. We'll show it with an arrow on our drawings, and that's how we can tell left from right if the joist design isn't symmetrical. So after all of that's done, after the paint dries a little bit, we'll load it up onto our trucks, maneuver them around the yard. We've got really good loading crews to kind of manage this because it can be quite a bit when we're busy. Maintaining all of these joists, and in a second, you'll see all of the deck, and making sure we know what belongs to what job so we can load the trucks when the job requires delivery. So then everything gets, secured on the truck. It's strapped down and then sent out to wherever the project location is. At which point the erector is going to take over and unload that truck, stage it on the ground, and prepare to fly it, up into the air to place it where it belongs. On the coil side, it follows sort of a similar structure where you've got your raw material, you have to prep it, you've got to cut it, and then in this case, stacking all of those sheets, bundling them, and then again, transporting it to the site. So those come with coils, and you can see a lot of coils here. So again, just for the different types of deck that we can supply, the different gauge thicknesses that can happen, 20 gauge, 22, 18, 16, all of that requires separate coils at different widths, different finishes, to make sure we can accommodate everything that we offer. And then that first step in the process is taking that coil, putting it onto that arm so that we can kind of unspool it and feed it into our system. So you can see here just, the variety and the quantity of coils that we have just to keep our operation going. Each one of those coils is generally about 20 tons, 40,000 pounds worth of material. So you can see it loaded onto the arm and then kind of having that loose sheet ready so that we can attach it to the previous sheet and feed it into our machine. Some of our Volcraft facilities will have inline painting Our Leduc facility doesn't do this. If painted deck is required, they're able to get it from one of our other facilities and have it shipped over. And then after it's prepped, sometimes we'll do different chemical treatments or whatever is needed for the finish that's required on that project. Then it gets fed into our rollers. So this is physically taking that flat sheet and starting to bend it and move it to the corrugated shape that's needed for that, that structural deck profile. So you can see here kind of being put through those rollers. Different embossments are put in depending on what's required. And then right here, that's the shear. So that's actually cutting the deck to length. And one thing you may notice is there's a lot fewer people on our deck line compared to our joist line. And that's just kind of what we found over time is the deck process can be mostly automated because it's really just kind of cranking out, that same product at whatever length is needed. Where the joist side, there's so much variation from one joist to another potentially that we need those human beings to place everything. And then as the deck comes out, it's going to get stacked, it's going to get bundled and stored, as you can kind of see here, and you saw a little bit at the end of the video, at which point, similar to joist, it would be put on a truck and sent out. So with all of this, we spent a fair amount of time talking about what the process is. And I'll hand it back to Sherrod for kind of how to measure all of the carbon that occurs throughout everything you saw the last 15 minutes.
I just got to jump to that EPD slide. Bear with me.
Yeah, we're used to Teams here in Volcraft, so we had to remind ourselves how to work Zoom this morning as we prepared for this.
It looks like it was asking me to choose to view your screen, Gerard, like it was side-by-side options and things like that, so.
I'll stop sharing.
There we go.
There we go, thank you.
Perfect.
Okay, so the good stuff, the environmental product declarations for joist and deck. So an EPD, what is it? Environmental product declaration. These are basically the nutrition labels that summarize the environmental impact of a specific material or product. Vertically integrated joist and deck companies are excellent at managing their supply of sustainable steel. And we see this through the life cycle assessment in a project. So there are three types of EPDs. One is industry average, which is more or less a starting point. It's nice to have, but it can be funneled down when you go down to something like a product specific EPD, which is better than an industry average. We can get even better results when we look at a facility specific EPD. So those are the most accurate numbers you can use to calculate the embodied carbon in your steel joist and deck. So those are the covers that we have for our joist and deck EPDs. We do have links at the end where you can access this information. So the life cycle assessment of a building, for all intents and purposes, when it comes to joist and deck, we're only concerned with the A1 which is the raw material supply, A2, the transport to the factory, and A3, the manufacturing portion, which is cradle to gate, excuse me. So, life cycle assessment results. EPDs are extremely useful here in order to get a full scope view of the carbon footprint of a finished building. We all emit CO2 when we commute to and from work. We know there's carbon in steel. However, the term GWP, or global warming potential, is a better way to represent what's really going on. The embodied carbon is the CO2 equivalent emissions that's created as part of the entire manufacturing process. So the question to ask is, how much greenhouse gas are we pumping into the environment? And while there are different parameters, the most well-known impact category indicator is that top line, that global warming potential. That's the one that all the steel companies are comparing to each other with. So when it comes to steel joists, at the top, we see there's that cradle to gate, the A1 to A3 life cycle. And again, that top line is your global warming potential. These are American industry average values from the Steel Joist Institute. That top line, 1.43, which is really 1,430 is the value when you're looking at your global warming potential. Steel deck, also very similar, represented the same way. Those numbers a little bit higher. 2,320 is the value that is also industry average. So Carbon Leadership Forum has this document. It's available to everyone. Just shows baseline values from the Steel Joist Institute and the Steel Deck Institute. For our use, we'll be able to dive deeper once the Canadian EPDs for Volcraft are issued, which should be very, very soon. We're hoping to have them in time for this. They weren't ready quite yet. When we're looking at EPDs, they can vary quite a bit when you compare who's representing what, whether it could be an industry average, it could be just a company average, but there's a big range there. So it's important to know just using an industry average won't give you an accurate picture of your specific project. And like I said, these are the cover pages for the Canadian ones. They should be ready, I don't know exactly when, but very, very soon. And also good to know that the values in these reports are third-party verified by Trinity Consultants. So these facility-specific values are for the Volcraft mills in the United States. The Canadian ones will be broken out between East and West, which will be really nice for projects in Western Canada. You'll be able to get the numbers from our Leduc facility. Just keep in mind, A1 is that raw material supply. A2 is the transport to the facility. A3 is your manufacturing process. And the total on the end is all those three added together. The Canadian numbers are expected to be on the lower end, around 750. It'll be pretty close to the Norfolk, Nebraska plant near the bottom of that chart. So here, when looking at, this is just the average of the weighted average of the 7 Volcraft facilities that we just saw on the previous slide. The average values for the Volcraft joist EPDs are 8.39 or 839 compared to industry average values in the United States, 1,430. So quite a big spread between what's represented in the industry average compared to what's shown in the Volcraft joist EPDs. So what to keep in mind when you are designing your projects, if you're looking at something like steel beams, your GWP number could be upwards of 1,220. Compare that with using steel joists in your project, you're down around 839. So that's about a 32% reduction in your embodied carbon per ton. Additionally, you're saving about 20 to maybe 40% in weight savings by selecting open web steel joists over steel beams. Here we just see a comparison of the different product category rules. Steel represented in the units of 1 metric ton, wood represented in 1 cubic meter, and then same thing for concrete represented in cubic meters. So you got to be careful when you're comparing the values across different building materials. They're not always the same, and there's not always life cycle assessments for each product. Whereas steel, you see you've got 3 of them, wood's got all 5, concrete's got 1. So it's not always an apple to apples comparison. When you do compare them, there's some math involved, and you should be comparing them for the same functional unit. It's kind of the same thing here. We want to make sure that when you're comparing them, compare apples to apples. Don't just take the numbers and expect them to tell you the same information. When you are comparing your construction materials, make sure it's fair across all 3, wood, carbon, and steel. Make sure you're using the same safety codes, life cycle span, use the same strategy, designing for the least amount of material, and express them in the same units. So how can you specify sustainable steel in your projects? Well, incorporating sustainability criteria in your specification language could be a way to select the lowest carbon version of a given product and motivate the industry to adopt greener solutions for manufacturing construction products. This example here in green, what you're doing by just following this type of example, you're just asking for the EPDs. The values themselves are not of a big concern to you. You just want to know that the EPDs are available. This one is a little bit different compared to the previous slide. This method requires a certain threshold to be met. In other words, the EPD values, they actually matter in this example. So if you want to be more specific, you can put in a requirement like this in your spec. And you can even go one step further in an example like this. Basically, you're directing the steel manufacturer how to form the steel or how to make the steel. You're identifying what percentage of scrap must go into the steel making process. This slide is great. We've got 3 different options here. If you scan that QR code, it'll take you to Nucor Sustainable Steel Spec Writing Guide. The second one will take you to kind of a pre-written joist and deck spec, or section 052100. It's kind of already written out for you. You could do a copy paste and put that into your spec, or you can modify it given the project that you're looking at. And the last one is the Structural Engineers 2050 Drive to Net Zero initiative. And while it's not like the one above it, where it's got a spec written out, it does give you guidance on how you can write your spec. So let's get to the end of this because I know everybody's time is important. So reduction is key. If everyone made steel like Nucor, that would be like grounding the entire airline industry twice. So I always thought that one was pretty cool. Nucor's 2030 carbon reduction strategy. We will continue to reduce the consumption of fossil fuels. We are exploring the use of biofuel substitutes in place of, to power our electric arc furnaces. We're pursuing a series of projects that will reduce natural gas usage or replace processed gas with low or no carbon technologies. So we're doing our part by aiming to reduce our carbon. You can help by asking for carbon reduced steel on your project. Just to sum it all up, what can you do to help? Let's specify some thresholds for global warming potential in your projects. Dictate where your steel is procured, perform those LCAs, and design your project using higher strength materials. A lot of steel makers do offer 50 KSI or 55 KSI steel. There is 80 KSI steel available. Might want to go down that route, get higher strength steel, and then maybe you'll need less steel in your project. And there's that QR code. I'll turn it back over to Alex, but there's that QR code. I'll leave it up on the screen. You can scan it for your credit. That brings us to the end of our presentation. Like I said, I'll leave that screen up so you guys can scan that.
Well, yeah, thank you all. And yeah, just thank you for the questions in chat throughout. Really appreciate you guys staying engaged. Yeah, so a question just came in if we're looking to partner with concrete to recycle cement. And I know the answer is yes, without knowing much beyond that. I know the slag that gets produced in our steel making, a lot of that material is sold and sent to cement manufacturers so that they can use it in their mixes to make the concrete more sustainable. And then we're also investigating, just other innovations with concrete, different mixes, since a lot of concrete does get poured onto our metal decks.
Yeah, thank you. I definitely want to point everyone to the discussion in the chat. There's been some really good discussion around just industry standards and what's happening around the world and the world's, international steel compared to North American steel. And then also the all important word for LCAs, which is baselines. So any other, we do have one question for us. Go ahead. Actually, I think, oh yeah, sorry, if your audio is on, go ahead. I couldn't recall.
Yeah, can you hear me?
Yes.
Great. Yeah, I appreciate the presentation. Thanks a lot. I was wondering if you could speak to the steelmaking process, especially for electric arc furnaces, and where those emissions come from. My understanding is that it is related to the chemical process of steelmaking, or is it more dependent on the electricity source for that steel? My understanding is that even if you're powering those EAFs off of renewables, that they wouldn't necessarily be lower carbon because there's a chemical process that happens in that steel making, which emits carbon emissions. But I wanted to check that with you and see kind of why, even in electric arc furnaces, we have values of around 0.8 kilograms per kilogram of steel.
Yeah, no, excellent question. Yeah, the majority of carbon emissions does come from the electricity production that feeds into that process. But you're absolutely right. The chemical reactions emit, some carbon as well. I couldn't tell you the exact breakdown, or that ratio from one to the other, but I know the majority of it does come from the electricity.
Thanks.
Sorry.
Fantastic.
Oh,
do
I
we have
have
another
one question. Yeah, firstly, thank you for the great presentation. I have a specific question related to the project. Like, my name is Dhruv, I'm with Stantec. So we are working on one project in Yellowknife region. So basically that facility has solely like a 14% of embodied carbon emission that's coming from the open web steel joist and the steel decking. So like as you mentioned, like the Canadian EPDs are going to come soon, but do you have any approximate timeline or something so we can contact you guys? Because uh like the construction phase hasn't started, so we just want to make our decision right on the point so we can connect with probably with them and say you on this part. Yeah.
Yeah, if you want to reach out to me, I would be the
Mhm.
best contact for that. To be honest, we were expecting our EPDs to be ready for this presentation. So they're still in the draft stage, which is why they haven't not been publicly released yet, but they'll probably be available. Like we were joking about it, Alex and I said they'll be available 5 minutes after this presentation is done. They should be ready very, very, very soon.
Okay.
We were told the last week that they would be released last week. It's like perfect,
Yeah.
right in the nick of time, but unfortunately they got delayed.
Sure. No, I would like to connect with you guys and like what I can do best from my end. And if you can drop your email here, or is there any way I can get your emails? Yeah.
I'll put it in the chat right now.
Yeah, that would be great. Yeah.
Yep. And then I put that last slide up as well, just with our info, and then also the QR code if anyone hasn't grabbed it yet.
Sure.
I do
Perfect.
think
Yeah.
we have one more question in the chat. Do you know if the product category rule for the joists and decks is specific to these products?
Yes. So these would be product specific for joist and deck. It's separate from, say, like the coil production or like a wide flange beam or like any other steel shapes. This will be unique for joist and deck.
Fantastic.
And
Okay,
Forrest,
and
I
yeah,
do see
Forrest
your
has his
email there,
information there.
so I'll grab that, and yeah, Alex and I will chat and get back to you, Forrest.
Thank you. Thanks, everybody. Fantastic discussion. Love to see the chats about what's happening, especially for Alberta and even, of course, the Yellowknife region. So thank you, everybody, for your input, and a special thank you to Gerard and Alex for sharing. I know I found seeing the video of how it actually happens invaluable. Like, I think, you can write LCAs on a computer and compare numbers, but to see the process was very informative. So thank you.
Yep. Thanks for having us. It was great meeting you all. And
Yeah, appreciate it.
Thank you.
Okay. Yeah, keep tuned, everybody. We'll have some fall events hopefully lined up soon for CLF Alberta. And then as always, the newsletter through ENBIX is the place to find all our upcoming event information. So we cannot encourage you enough to sign up. So thank you, everybody, and have a great afternoon.